Hi, folks. Some folks have been asking me about how I do documentation for my project. So this is a little presentation on what tools I use, how I do it, and a little bit more information on the 3-tube amplifier. It's got lots of wiring, so I kind of need to do this while I'm building. Requirements for my tools, mostly cheap, free, easy. I'm basically a pretty lazy person. So I don't like buying stuff that's probably something I can do with my existing software. And here they are. While I'm doing wiring, I often make sort of a pictorial representation of the terminals. I use Excel spreadsheet for this, and I mark all the wires. And I have a little shrink wire label maker that I tag all the wires so that I can keep track of what I'm doing. This really pays off when you're developing stuff and trying to make it work. And of course, later to service anything. Highly, highly important. This is a little diagram of things that are going onto the Arduino CPU board and coming off the CPU board. So basically the inputs and outputs that are going to the board. This is what the little remote control panel box is going to look like. It sits on desktop. It's only small, maybe 4 by 6 on the front. And I have thought out what it's going to look like and what the controls are about, and I started a interface cable wiring diagram. So this helps me sort out what's important, and I'll build it around this. This little schematic is out of date, but it represents the control scheme that I'm going to use the Arduino to implement. But it's a little out of date now. It needs updating. It's actually gotten a little simpler. This is the grid input scheme, the exciter drive, 3 tubes all running in parallel, and I've got a step-up transformer to increase the voltage. Tetrode drives, grid drives don't need much current, so that will work, and I can switch that in and out with a remote relay. This is the output tank for the 3 tubes, and it shows the controlled elements. It's a pi type tank, 2 capacitors and a inductor, and there's some relays to switch in some extra inductance and capacitance as required. This is the high voltage power supply. It's built around the requirements of the 3 tubes, plus 2 donated high voltage transformers were given to me by Roger, VA1 RST. And I have arranged to build like a dual power supply that's combined into a voltage doubler circuit. But this has been tested on breadboarding on a system with a load, and it works just fine. So this is the high voltage power supply. This last little diagram is the balancing system I use for the tubes. I put a little bias on each of the cathodes and adjust them to make the tube gain look the same for all of them. This is a 2-tube version, but I actually have a 3-tube one in mine. It's exactly the same, just one more element. And I make these things with Eagle CAD and route the boards on a little router. And it's not unique to me, but putting them together and balancing tubes, I haven't really seen anybody else doing this. But I've tried it on Roger's amp. It worked very well. He's been using it all year. So this is the scheme for mine as well. A little interesting note. Just for fun, I asked ChatGPT how this little bias circuit worked, just to explain to me how people balance tubes, and based on this system that I'm doing here, and it gave me a quite correct answer. You can read it here at the bottom of the page. It was very entertaining. So that's a little update on the 4CX250B amplifier project and the tools I'm using to document the construction and testing as I go along. So until the next report, stay tuned.